Here's another great classic problem. You launch a ball or some projectile straight up into the air at some known initial velocity, and you want to know how high it will go and how long the round trip up and down will take. Now, the thing that allows us to even solve problems like this at all is that the velocity at the top of the journey is known. The velocity just before the object starts to fall back to Earth is 0. And from these two velocities, initial and final, we can calculate an average velocity, which is just the numerical average of the two, 38 meters per second plus 0 meters per second divided by 2 is 19 meters per second. So there's our average velocity. Now the acceleration in a problem like this ball actually is accelerating. It's just accelerating downwards. The acceleration is 9.8 meters per second in the downward direction. Now we can use that acceleration to find the time in the air. Acceleration is delta v over delta t, and so delta t is delta v over the acceleration. The change in velocity delta v is just 38 meters per second, and the acceleration is 9.8 meters per second squared. And we can cancel these units, and we'll have units of 1 over seconds, which is what we're after. And so delta t is, in this case, 3.878 seconds. Now distance is average velocity times time, and so we have both of those. We have our 19 meters per second times 3.878 seconds. Seconds cancel, giving us units of meters, and so the distance that this ball travels is 73.67 meters. So that's how high it goes. Now with any projectile like this, the time up is equal to the time down, or vice versa. So the round trip time is just twice the time that it takes to get up, so that's 2 times our time, which is 7.756 seconds. So for this projectile, the ball will reach a height of about 74 meters in 3.9 seconds, and then it'll take another 3.9 seconds to return to the surface.